All right, let's get into it. Today, we're going to talk about a pretty surprising discovery, one that was almost found by accident, and it completely flips how we should be thinking about AI memory. Seriously. It's about shifting from seeing our AI as just a digital filing cabinet to seeing it as a brilliant intern that actually learns on the job.
Does this feel familiar? You spend all this time showing your AI assistant exactly how to do something, you get it just right, and then, the very next day, you have to explain it all over again. It is so frustrating, right? It feels like you're working with this genius who just has a terrible case of digital amnesia. But what if the problem isn't the AI's memory at all, but the way we've been told to use it?
So here's the core idea. There are two totally different ways to think about this whole memory thing. On one side, you've got the standard way we all do it. We tell the AI to remember our name or our coding style, simple preferences. It's basically passive storage. But on the other side, there's this new, emergent way of thinking that was discovered, using memory to actively learn and validate patterns that you can use again and again. And that is where things get really cool.
Okay, so let's dig into the problem with a standard approach first. Most of us, right now, we treat our AI's memory like a digital attic, or maybe a messy filing cabinet. We just keep throwing information in there, hoping it'll come in handy someday. But as the research shows, this actually leads to some pretty big problems.
Now take a look at this. This chart shows what we're actually putting into that digital attic. A survey found that the vast majority of what we save are things like personal preferences. That's a whopping 87%. And basic project facts. The really valuable stuff, the reusable domain knowledge, that's only about 22%. We're essentially filling the attic with clutter, not treasure.
And this chart just nails the core problem. Look at this. Users are creating memories in about 42% of their chats. That's a lot. But how often do those memories actually get used to solve a problem? Only 35% of the time. There's a gap. We're constantly adding stuff to the pile, but we're barely using it. We're just creating digital junk.
And here's the human side of it, which is just so relatable. Over 60% of people surveyed basically said, I have no idea what I've even told my AI to remember. That digital attic gets so cluttered that it becomes totally useless. It's a write-only system, and that's just a fundamental flaw in the design.
But what if there's a better way? Well, the solution here didn't come out of some big, fancy tech lab. Nope, it just emerged. It came from a single developer who was just fed up with repeating themselves, and their journey led to this incredible accidental breakthrough.
So this developer's story starts with pure frustration, right? Solving the same coding problems again and again. By week 6, they started saving successful patterns into the AI's memory. But the real aha moment, the breakthrough, came around week 14. They realized they hadn't built a filing cabinet at all. They had accidentally created a validation pipeline, a system where only the most useful patterns actually survived.
So this new system, which eventually got the fancy name Sparse Contextual Memory Scaffolding, or SCMS, it just flips the old model completely on its head. Instead of passively storing information, it actively tests and validates it. It basically treats memory like an automated test suite for your knowledge.
Okay, so here's how it works, broken down into 4 simple steps. First, any new idea or pattern goes into a temporary testing layer. Second, a pattern only gets validated if it proves it's useful by being reused. Third, these validated, kind of battle-tested patterns get promoted to a permanent layer that the AI is forced to check every time. And fourth, this is the magic part, all the useless patterns that never get reused, they just fade away. It's a self-cleaning system. And the developer who found this had this amazing insight. Their memory system was working exactly like an automated test suite. Creating a temporary memory, that's like writing a new test. When a situation comes up where you can reuse that pattern, that's like running the test. If it gets used a couple of times, the test passes and the memory gets deployed into your permanent knowledge base. And if a memory is never used, well, the failing test gets removed. It's like natural selection for your best ideas.
So okay, we've got this really elegant new theory for AI memory. It's a great story, but does it actually work in the real world? Well, the data that came out of this experiment is, and I'm not exaggerating here, it's astonishing.
I mean, this is the real question, isn't it? Does changing how we think about memory from a filing cabinet to a test suite, does it really move the needle on performance and efficiency? Let's take a look at the numbers. The results are just
Wow. Compared to the standard way of doing things, this new SCMS system cut the time spent refiguring out the same problem by 91%. It boosted actual knowledge retention by 154%. And get this, it almost completely eliminated documentation lag, that gap between finding a solution and actually writing it down, by 98%. This isn't just a slight improvement, it's a total game changer.
Let's just pause on this number for a second. A 91% reduction in rediscovery time. Just think about all the hours you've wasted trying to remember a solution you found before. This system basically makes that entire category of wasted time disappear. It's the difference between fumbling around in a dark attic and having a spotlight shine on the exact answer you need right when you need it.
And you know what? This isn't just some niche trick for software developers. The researchers tested this SCMS model in a bunch of different fields and found incredible results everywhere. Scientific researchers cut down their literature search time by 73%. Content creators had 64% fewer revision cycles. Data analysts spent 81% less time debugging. This is a fundamental pattern for how we can work with AI better, no matter what you do.
So, with results this powerful, you'd think every AI company on the planet would be building this into their products. But here's maybe the most surprising part of the whole story. This technique wasn't a product, it was a discovery, and the research shows just how few people have actually stumbled upon it themselves. This is the real kicker. The researchers estimate that fewer than 1% of all people using AI assistants have naturally figured out this validation-first approach. Almost everyone is still stuck in that digital attic mindset, because that's just how the tools are designed and marketed. This incredibly powerful method is hiding in plain sight. So this is a really important distinction to make. This isn't what you'd call an adoption crisis, where people know about a better way but just don't want to change. No, this is a discovery gap. The vast majority of us don't even know that this more powerful way of using AI memory is even possible. The tools themselves don't guide us towards this much smarter workflow.
So how do we fix this? Well, the paper proposes a really neat concept called mandatory UX. The idea is to just build this validation pipeline right into the user interface of AI assistants. Imagine if every time you save something, the AI just asked you, hey, is this a simple preference or is this a testable pattern? It would make this powerful learning method the default for everyone, not just the tiny 1% who happen to discover it.
And all of this leaves us with a pretty fascinating thought to end on. We spend so much time and energy talking about making AI models bigger, stronger, faster. But what if the next truly giant leap forward in how we work with AI isn't about giving it a bigger brain, but about giving it a fundamentally better, more active memory? What if the real key is teaching our AIs not just how to remember, but how to learn?